Good afternoon, finance class. This section is really interesting. It covers the data that we look at in an accident, like skid marks that are left on the road, and determining the cause or if the person was going the speed they were supposed to. So, interesting section. We have a few formulas. So, one is the skid speed formula. So, using this, based on our skid marks, we can look at how fast the car was traveling. So here's the formula. I'm going to go over what each letter represents. So D would be the skid distance. And we're going to use this formula a lot. F is our drag factor. And N is the efficiency of our brakes, or braking efficiency. So this could have to do with how new your car is, how good your brakes are, have you had braking pads, everything like that. So those are the three variables determining, looking at your skid marks of the car, you can look at how fast the car was traveling. The next are called yaw marks. Now, I've never heard that term before until this class, but I know what it's talking about. So yaw marks are made when a car spins out, so it makes curved skid marks or curved tire marks when your car is sliding sideways, but you're still propelling forward. Okay, so and I have two formulas, but I'm going to draw you a picture. So let's say here's my curved skid mark. Okay, I would use this, think of that as like the height of the mark, but they call this portion here, the height of that, they call that the M, which is the middle ordinate. Because this looks like a half circle or a partial circle, this line segment down here, in geometry, a segment that goes through a circle and hits the edge of each circle is called a chord. So that is where we get C, chord. And then each of these, the distance from the outside to the middle and the middle to outside would be R, and remember R is radius. So here are the formulas if we're looking at curved skid marks. These are the formulas. This formula here is for radius, and this again would be the speed the car was traveling given those skid marks. The last thing we are going to look at is a trajectory. So let's say you get in an accident and something in or on top of your car is thrown. So a trajectory is when an object is thrown, shot, or ejected upward. You could use trajectory to look at, like when you throw a football, it makes this perfect curve. It goes up and then comes back down. But in this class and in this section, we're looking at the trajectory of an object that's thrown from a car. So there are two formulas, and the book will give them to you. And the book and your homework will tell you which two to use. One will involve T for time. And so it'll look at the time it takes for that object to hit the ground. The other one will be the distance that object is thrown. So remember, when we think of trajectory, think of an item that is thrown, has kind of like a height, and then this down here, right, would be distance. But T is how long it takes to hit the ground. And they'll give these formulas to us. So I'm going to do quite a few examples so that you get everything that you could see in your homework. All right, so let's start with the first one. A car is traveling on a cement road. Here's our drag factor of 1.1. Here's our speed limit. It was determined the brakes were operating at 85% efficiency. The driver notices, and I want to note that this part right here is the speed limit, not how fast the car was traveling. The driver immediately applies the brakes, and the tires leave 4 distinct skid marks at 50 feet in length. So there's our skid distance. What is the minimum speed the car was traveling when it entered the skid? All right, so I'm going to use my formula, and I'll change so this sticks out. So The speed at which the car was traveling, we're using this first formula I wrote down, okay? So, and I know that because it gave me my drag factor, so there's F. Braking efficiency, that's N. And 50 feet in length, that is my D for the distance of my skid marks. So, the speed at which this car was traveling, here's the formula, 30. And it doesn't matter what order you write them in, so I'm going to just write them in the order that they gave them to me. 85% would be 0.85. Remember, we always have to convert our percents to decimals. And then my skid marks were 50 feet in length. So it doesn't matter what order you write down D, F, and N in. And then I'm going to simply enter this in my calculator, and it does say to round to the nearest tenth. So the square root of 30 times 1.1 times 0.85 times 50. And I get 37.45. It says to round to the nearest tenth, so I'm going to say 37, based on here, I didn't pay attention, if nearest tenth would be 37.4 miles per hour is S. So S is for speed, so this car was traveling approximately 37.4 miles per hour. Now, let's look at the speed limit. The speed limit was 45 miles per hour. So was the driver exceeding the speed limit? No. Okay, so the answer would be no because we figured out the car was only traveling this fast based on the skid marks and the braking efficiency. Number 2, highway, let me move that up a little bit more. Number 2, highway 21 has a surface drag factor, so there's F. I'm going to make a note of that. There's F. B is my braking efficiency, which in our formula is N. Is approaching an accident, causing the driver to apply the brakes. The tires leave 4 distinct marks at C feet each, but I know that my skid mark, notice it is the letter D. So they want us to write an algebraic expression to find the speed. So the speed of my car would be 30 times my drag factor. I don't know what N was. They just told me B, and they gave me the letter C for D. And I'm going to go ahead and simplify this because I have 2 numbers that using my calculator I could multiply. And if I multiply those, I get 21.6 BC. If you put CB, that's fine, but I like to put my letters in alphabetical order. All right, number 3, Mark was traveling. So this time they're telling me the speed at which he was traveling. So he's traveling 40 miles per hour. Here's my drag factor, 80%. They want me to the nearest tenth of a foot. What would you expect the average length of the skid marks to be? So in this formula, I'm going to write down my formula, 30 DFN. They gave me his speed. 30 is fixed. They gave me my drag factor. They gave me my efficiency. What I don't know, and they want me to find out, is his what would the skid marks be. So I'm looking for D. So I'm going to go ahead and simplify what I have. So using my calculator, I'm going to enter all of this in my calculator. And I get 40 equals the square root of 20.4 D. So I entered this. I hit 30 times 0.85 times 0.80, or just times 0.8. That's where I'm getting the 20.4. Now, in order to solve this, the way to get rid of that square root symbol is to square both sides. And so that's exactly what I'm going to do. So on the left, I'm going to hit 40 squared. I get 1,600. On the right, these cancel, and I'm left with 20.4D. So I'm going to divide by 20.4. I'm going to be doing a lot of solving today. And I'm going to round to the nearest tenth. So 1,600 divided by 20.4. It says, round it to the nearest tenth of a foot. So 78.4 feet. That is the expected length of the skid marks on the road based on how far he was traveling. All right. Number 4 is another one where they want us to write the algebraic equation, and I don't know if your homework's going to have you do that, so I'm going to move on to part 5. All right, so part 5 mentions yaw marks. So based on the notes we started with, it means I'm going to be working with these formulas. Determine the radius. So as soon as it mentions radius, I'm going to write down the radius formula. Radius equals my chord squared divided by 8 times m plus m divided by 2. And I'm using that formula because it mentions radius. Okay? So let's go over what they gave us. It says that my chord is 59.5 feet. I have a middle ordinate of 6 feet around to the nearest tenth. So I'm going to plug in what they gave us. They gave me a chord, C, of 59.5, divided by 8 times, they told me M. So what they gave me C is 59.5, and they told me M is 6. And so that's what I'm plugging in. So I plugged 6 in for M and 59.5. So I'm going to simplify this. I'm going to do the left first. So 59.5 squared divided by, in parentheses, 8 times 6. Whoops. And so I get 73. Whoops, 73. My bad. 73.70. It says round to the nearest tenth. I'll do that in a second. Plus 3. I'm going to round that to 73. Whoops. If I add 3, my final answer is 76.8 feet. That is my radius of my curved skid mark. All right, number 6. So now we get into talking about, like, what if you slam on your brakes and you leave different skid marks, like they're not all the same length. And so in this case, it says the police measured them to be the following: 45, 40, and 44. So when they use the formula, I can't use all 3. The formula we're talking about is this. I can only use one skid distance. I can't use all 3. So what we're going to do is find the average skid distance. So to find the average, they gave me 3 different ones. So I'm going to add up the 3 and divide by 3 because I have 3 different numbers. So 45 plus 40 plus 44 divided by 3, I got 43 feet. That is what we would use for our skid distance formula. So if you want to pause and then try this next one by yourself, that would probably be the most beneficial. So for this next one, it says her car left 4 skid marks. 2 were at 52, 2 were at 56. So what would be the average here? So you could write either 52 plus 52 plus 56 plus 56, right? There's 2 at 52, 2 at 56, which means I have 4 different skid marks. So if I enter that in my calculator, I got that the average is 54 feet. And so that is what I would use for D. This next one, if they do ask for an algebraic formula, I have 2 skid marks A feet long and 1 B. So to find the average, right, I have A plus B divided by 3, or I have 2 A's plus B divided by 3. All right, next one. Russell was driving on a gravel road. Here's the speed limit posted. A car ahead of him pulled out from a parking lot, causing Russell to immediately apply his brakes. He left 2 skid marks of 60 and 62 feet. Here's my drag factor, my efficiency. The police gave Russell a ticket for speeding. Russell insisted that he was driving the speed limit. Who is right? So let's figure it out. What was his speed? 30 is part of the formula. Here's his braking. Here is his drag factor. But I have 2 different numbers for D. So D is going to equal the average of those two. So if I divide those two by 2, I get 61. So I'm going to enter all of that into my calculator. So the square root of 30 times 0.95 times 0.47 times 61, and I get 28.6 miles per hour. So the speed limit was 20. So who's right, the cop or Russell? The cops were correct. He was speeding. Okay. All right, we have a few more, well, quite a few more. So this next one is very similar to the last one, so I'm not going to do it. Number 11. A car is traveling at 52 miles per hour. So they've already told us the speed. Here's the drag factor, efficiency. How long might the skid mark be? So here's the formula. I'm using that speed formula again. They already told me the speed the car was traveling. They've told me my what I'm just plugging in what they've told me so far. And so I'm missing D. D is my skid distance. They gave me F and N. And so I'm going to enter this in my calculator. And by enter this, I mean the numbers that I have. I'm going to enter. And I get 22.704D. Now, if you'll remember, the only way to get rid of that square root is to then square both sides. I'm going to write the results here. So 52 squared, I got 2,704. This side cancels, so I just get 22.704D. I'm going to divide both sides, and I got that D would be 119.1 feet. So that is what we could estimate how long the average skid mark would be based on how fast he was traveling. All right, next one. And this one is just like 11, so I'm going to skip. And so I'm going to go to 13. So for this one, they gave us her speed. She was traveling at 45 miles per hour. She left 2 skid marks, but they already averaged it for us. They had a difference of 6 feet between them. Her brakes were operating at 90% efficiency. What was the possible drag factor? So they want us to find F and what were the integer lengths of each skid mark. So let's plug it in. She was traveling at 45 miles per hour. 30 times her skid mark distance, her braking efficiency. I don't know F. So we're first going to solve for F. Enter what you have in the calculator. So 30 times 60 times 0.9, I get 1620 F. Okay. Remember, to get rid of, I'm going to square both. So in my calculator, 45 squared gives me 2,025. On the right, these cancel. So now I'm dividing both by 1620, and I get that F equals 1.25. The second part was they wanted us to find the different integer lengths of each skid mark. So they told me the average was 60, but the difference of those two were 6 feet between them. So this is the middle, or the average, of 2 skid marks that are 6 feet apart. Well, then this would have to be 57, and this would have to be 63. And I know that because 60 is in the middle, and these are exactly 6 apart. So these would be the distances of the skid marks, or these would be the measurements. All right, last couple. So this has to do with the yaw marks. So we're going to finish up our lesson here. And they want us to find the radius. So I'm going to write that formula. So what is the radius of the curve? If there's M, here's C, and they want us to round to the nearest foot. So R equals, my chord is 39, so 39 squared. M is 5.3. And so I'm going to at least do each separate. So 39 squared divided by, in parentheses, 8 times 5.3. I get 35.87 plus, this next part is 5.3 divided by 2. I get 2.65. So I'm going to add that to 35.87, and I'm going to round. So 38.5 is my radius, so 38.5 feet. Last two, and for this next one, I'm using the same formula, but this time they want me, what was the length of the chord? So I'm looking for C. So they've told me that the measure of my yaw mark is 7. Okay. The radius is 64. So 64 equals C squared. Oh, sorry, the middle ordinate is 7. So C squared over 8 times 7 plus 7 over 2. So I'm going to simplify what I have. 64 equals C squared over 56 plus 3.5. 7 divided by 2 is 3.5. So to solve for C, I would subtract 3.5 from both sides. So that would give me 60.5 equals C squared over 56. Right? To get rid of 56, I would multiply both sides. Look at all this review from Algebra 1. I'm sure you're excited. And that gave me C squared equals 3,388. So to solve for C, I would take the square root, and C equals 58.2 feet. All right, last one, and this is very similar to how it is in your homework. So they've given me the data. I have a car traveling at 35 miles per hour. The cargo is secured at 5 feet. During an accident, the cargo flies off the car. So they want me to use this for the time it takes for the cargo to hit the ground and use this formula for the horizontal distance. Okay, so how long, this is referring to time. So I have y equals negative 16.1, and I'm going to switch that. I'm going to change y. I'm solving for t, and they told me the height is 5. Now, what do I put for y? When I am talking about it hitting the ground, you're going to substitute 0 in for y and then solve. So I'm going to subtract 5 from both sides. So negative 5 equals negative 16.1 t squared. I'm going to divide. So t squared equals, I get 0.31056. To solve, I'm going to take the square root of both sides. So t equals 0.56 seconds. So less than 1 second it would take for, let's say it's a suitcase, for the suitcase to hit the ground. That's pretty accurate. If you're driving that fast, boom, it's going to hit. If it flies off the top of your car, it's going to hit the ground pretty fast. How far would the cargo travel, right? Have you ever seen something fly off on the freeway and it could travel forever? Okay, so how far would the cargo travel after hitting the ground? They asked us to use the second formula. So y equals negative 0.006 x squared. H is the height of our object, which is 5. Now, when I'm solving this, I'm going to set y equal to 0. To solve, I would subtract 5. So negative 5 equals negative 0.006x squared. Divide by your decimal. So I have 833.33 equals x squared. I'm going to square root both sides, and I get that my cargo would travel 28.9 feet. And I'm guessing this isn't that far because they're not on the freeway. It was only driving 35 miles per hour. But that is it for that section.